Welcome to our video lecture on the law of conservation of mass and balancing equations. Our objectives for today, we're going to define the law of conservation of mass, practice counting atoms, and then we're going to learn some methods for balancing chemical equations. So the law of conservation of matter, we can also call this conservation of mass. We use those two words interchangeably. Simply states that matter can neither be created nor destroyed. Everything that we have has to come from some place and it has to go someplace. We just can't make things appear or disappear. Definitely get this guy memorized because I'm going to ask you to write it on a quiz. So how this applies to chemistry, let's say that I've got 32 grams of oxygen gas and 4 grams of hydrogen gas, and they're going to react to produce water. Well, all the grams of water that we can make have to come from the grams that we're starting with. And we're starting with 32 grams and 4 grams, and we combine those oxygens and hydrogens to make water. We can make a total of 36 grams of water. So how many grams of water can be formed? 36 total grams. Let's practice in some equation style problems. So I like to draw a line between my reactants and my products just to make sure that I'm keeping everything organized. And I'm just going to do some algebra, my friends. So I'm going to take 17 grams and some number of grams of hydrochloric acid. I'm going to pick a variable. I'm going to pick X, but you should pick your favorite variable. Set that equal to the total on the other side, 53 grams of ammonium chloride. Solve for X. Subtract 17 from both sides. Whoa, that was a weird subtraction thing. Ignore that line. Anyhow, so I get 36 grams of hydrochloric acid needs to be reacted with 17 grams of ammonia in order for us to make 53 grams of ammonium chloride. Let's do this next one together, and then on the following screen, you're going to do it on your own. So this one, again, we're just going to take the two sides. We're going to combine them, 12 plus 10. We're going to combine everything on the other side as well, 14, and let's pick, oh my gosh, we're going with Y today. Combine your like terms, so much algebra. That's 22 on the left in the reactants, and then I have 14 plus Y on the right in the products. Solve for Y, subtract 14 from both sides, and it looks like we're going to get 8 grams of silver chloride. This one is yours to do on your own. And hopefully you realize that we totally did this problem at the very beginning of the lecture, and 4 plus 32 is going to equal X. X needs to equal 36. Once again, 36 grams of water. So not only do we need to balance masses in our equations, but we also need to balance the numbers of each kind of atom. This picture is kind of amazing at describing that idea. So I have two H2s and an O2. So again, we're looking at hydrogen gas and oxygen gas making some water. So two H2s, what that means is that I have two molecules, 1, 2, of hydrogen gas. Remember that hydrogen is diatomic. Our mnemonic device for the diatomic elements is Brinkelhoff, Br2, I2, N2, Cl2, H2, O2, F2. If you have any of these elements, they're going to come in pairs, in twos, because they're diatomic. So anyhow, we've got two molecules, 1, 2 of hydrogen gas. H2 means that I have 1, 2 atoms of hydrogen, 1, 2 atoms of hydrogen in each of these two molecules of hydrogen gas. And then I have, there's an invisible one here, 1 molecule of oxygen gas. It's also diatomic, so I have 1, 2 atoms of oxygen in this 1 molecule of oxygen gas. And that's going to make 2 molecules of water. I have H2O, here's my 1, 2 H's and an O, here's my 1, 2 H's and an O. There are 2 molecules, 1, 2 molecules of water. What's super cool is if I count all of my atoms of each element, they're equal on both sides. So I have 1, 2, 3, 4 atoms of hydrogen on the left in the reactants, and I also have 1, 2, 3, 4 atoms of hydrogen in the products on the right. Oxygen, there are 2 atoms on the left, and then there's also 1, 2 atoms on the right. So we have matches of each of our kinds of atoms, both in the reactants and the products. Before we can start doing those balancing, we need to make sure that we know how to count the atoms in formulae. So this one's pretty easy. We're just going to use those subscripts, and they tell us how many of each kind of atom we have in the molecule of, this is glucose. Hopefully that's a reminder from bio. So there are 6 carbons, and there are 12 hydrogens, and then there are also 6 oxygens. Good. This one, how many atoms of calcium hydroxide? So calcium's easy. There's only one, because if there's not a number, it's an invisible one. Oxygen and hydrogen, be careful. Those parentheses, again, kind of like in math class, we're going to use distribution property. I have 2 oxygens and 2 hydrogens. So do make sure that you're thinking about that distribution piece when we're looking at our subscripts outside of parentheses with our polyatomic ions. All right, this one is yours to do on your own, my friends. All right, hopefully you figured out that there are 3 nitrogens, and 3 times 4 makes 12 hydrogens. There's only 1 lonely phosphorus, and then there are 4 oxygens. So using that little skill, we're going to go ahead and start balancing some equations. We want to make sure that we have the same number of each kind of atom on each side of our equation. So again, I like to draw a line between my reactants and my products, just to make sure, once again, that I'm keeping those pieces organized. What I like to do, and this is not the only method for balancing equations, but this is one I'm going to teach you first, I'm going to count the number of each kind of atom on each side of my equation. So I'm going to list nitrogen and fluorine, because those are the 2 kinds of atoms that I have on both sides. There should always be the same elements on both sides. If not, there's something wrong with your chemical equation, because we can only change those elements in nuclear equations, and we're definitely looking at chemical equations now. Now I'm going to count how many atoms of each I have. So I have 2 nitrogens, and I have 2 fluorines, and then on this side I have 1 nitrogen, and I have 3 fluorines. This is not a match. I need to have equal nitrogens on both sides. I don't. I need to have equal numbers of fluorines on both sides. I don't. And so what I can do is not change the chemical formula. I can't just turn that into a 2 and turn that into a 2 and call it done, because then I wrote an entirely different chemical equation, and that's not what we can do here. What I can do, though, is change the numbers of molecules of these chemicals that I have. So I have 2 nitrogens over here. I only have 1. I need more nitrogen. And so what I'm going to do is put a coefficient of 2 in front of NF3. So now I have 2 times N. I have 2 nitrogens. But I also have 2 times 3. I have 6 fluorines. So my nitrogens are a match. That's good. My fluorines are not yet a match. I have 6. I only have 2. So what I'm going to do is come back over to my reactant side, and I'm going to get more fluorines. And how I do that is by putting a coefficient in front of the fluorine. I'm going to do a 3, because 3 times 2 makes 6. And now I have 6 fluorines on this side and 6 on this side. We have a match. And so my balanced chemical equation is going to be, this is an invisible 1. You can write the 1 if you want to, but you don't have to, but you can if you want to. So we're going to have 1 nitrogen and 3 fluorines, and that's going to make 2 nitrogen trifluoride molecules. Good? All right, we're going to do a couple more together, and then I'm going to have you do some on your own. All right, so once again, I like to draw a line between my reactants and my products. I'm going to list out my elements. They should always be the same elements on both sides. I'm going to count. I have 2 hydrogens to start and 2 oxygens to start in my reactants. I have 2 hydrogens to start. Oxygen is kind of tricky in this one. I have 1 here and 2 more over here. So we have a total of 3 oxygens. Oxygens are not a match. I have 3, I only have 2. So I'm going to add some more over here. But the only thing that I can do is to change the number of coefficients. So I'm going to put a 2 here. I've messed everything up. Now I have 2 times 2 makes 4 hydrogens. 2 times 2 makes 4 oxygens. Nothing matches still. But that's okay, because if I go back over to my product side and I put a 2 here in front of the water, now notice that I have 2 times 2, I have 4 hydrogens. So I got my hydrogens to match again, and here's the magic. Are you ready? 2 times 1 oxygen plus 2 oxygens, 2 plus 2 makes 4. We have a match, my friends, 4 and 4. And again, if you want to put a 1 in here, you can. If you want to leave it blank, that's fine. If it's blank, we're assuming there's an invisible 1. We're going to do one more together, and then I'm going to have you do the next on your own. Okay, again, divide reactants and products. I'm going to list out my elements. I have 1 sodium and 2 oxygens, invisible 1. Oh, that looks like a 0. Invisible 1 and 2 and 2 and a 1. So close. We have the same numbers, but in the wrong places. So I'm going to go ahead and add some more sodium. I've got 2 here and only 1 here. So I'm going to put a 2 here. So now I have 2 sodiums. I have a match on my sodiums. My oxygens still do not match. I have 2. I have 1. So I'm going to put a 2 up here in front of my sodium oxide. So now I have 2 times 1. Yay! I've got 2 oxygens. Oh no! I also have 2 times 2 makes 4 sodiums. So when I made my oxygens match, I messed up my sodiums again, but that's okay because this is a beautiful process of guess and check and guess again and check again. So what I'm going to do now that I have 4 sodiums, I'm just going to go back over to my reactant side. I'm going to change that 2 to a 4. There we go. I'm just going to scribble out that 2 and make it a 4. So now I have 4 times 1. I have 4 sodiums. 4 sodiums, 4 sodiums is a match. 2 and 2 is a match. And my final balanced equation, 4 sodiums, invisible 1 oxygen, 2 sodium oxides. Good? All right. Perhaps consider working in pencil on these problems. All right. Next problem is yours to do on your own. All right, so real quick, ALHCl, ALHCl. We've got 1, we've got 1, we've got 1, we've got 1, we've got 2, we've got 3. 3 chlorines, 2 hydrogens, 1 aluminum. So I'm going to start with my hydrogens. I've got 2 here and only 1 here. I'm going to put a 2 in front here. So now I have 2 and 2, still not a match. I need more. So this one is kind of tricky because I've got 2 and 3. I'm going to use my least common multiple of 2 and 3. That's 6. So what do I need to put in front of this guy to get 6 chlorines? This needs to be a 2. So 2 times 3 makes 6. And then over here, what do I need to put in front of my hydrochloric acid to get 6? I need a 3. So I'm going to get rid of this 2 in front of the hydrochloric acid. I'm going to turn it into a, whoa, I'm going to turn it into a 6. Turn it into a 6. 6 times 1 makes 6. But now I also have 6 hydrogens. Oh, I only have 2 hydrogens, but I can fix that. There's a 3. 3 times 2 is 6. I also have 2 aluminums here, my friends, so I need to change this one into a 2. And so your final balanced equation should be 2, 6, 3, 2. Here's another one for you to do on your own. And again, we've got Mg, we've got H, we've got Cl, we've got Mg, we've got H, we've got Cl. I have 1, I have 1, I have 1, I have 1, I have 2, I have 2. This one's easy. I just need to double these 2 guys, and I can do that by doubling this guy. So now I have 2 hydrogens and 2 chlorines. I have 2 and 2 and 1. Done. And again, you can leave this 2 here, and your other blanks can stay invisible ones, or you can go ahead and type in the ones. One more for you to do on your own. So I'm going to take a little bit of a shortcut this time. If you don't like the shortcut, ignore it. So instead of listing out my reactants and products, I'm just going to count in the formula. So I see 2 hydrogens here. I need to put a 2 here. I now have 2 chlorines. I'm going to put a 2 here. I have 2 chlorines, but I also have 2 sodiums. I'm going to put a 2 here. And now I'm going to count, but not by listing, just by counting. I have 2 sodiums, 2 sodiums. I have 2 hydrogens, I have 2 hydrogens. I have 2 chlorines, I have 2 chlorines. We're done. Balanced equation 2, 2, 2, 1. If you like listing them out, you should list them out. If you're feeling good and you want to take that little bit of a shortcut, feel free to take that little bit of a shortcut. All right, so sometimes I'm going to ask you to write the equations and then balance them yourselves. So in this example, magnesium and hydrochloric acid react, forming magnesium chloride and hydrogen gas. Magnesium is Mg, and means add or plus. Hydrochloric acid, you've got to know those formulae from last semester for sure to get this problem done. This is going to make magnesium chloride. Our yields sign, that arrow with the yields sign, is going to show us that we're making stuff. So magnesium chloride is going to be MgCl. Remember that magnesium has a +2 charge and chlorine's a -1 charge, and so I need 2 of those guys, MgCl2, and then hydrogen gas. Hydrogen is diatomic, so it's got to be H2. So now I can go ahead and think about, what do I have? Reactants and products. I have 1 magnesium, 1 magnesium, 1 hydrogen, 2 hydrogens. I need to fix that, put a 2 here. My 2 hydrogens also gives me 2 chlorines, which is good because I definitely have 2 chlorines right there. Equation is balanced. And again, if you want to throw in those ones, you can, but you don't have to. You could definitely leave those spots empty, and it's assumed that there's an invisible one there. I'm going to have you do this one on your own. All right, so we're going to write this equation, tin 2 fluoride. This is tin with a +2 charge. Roman numeral 2 tells us +2 charge. Fluoride is a -1 charge. I need 2 of these to balance that out. So I'm going to have SnF2. And is our plus. Dinitrogen trioxide. That's 2 nitrogens and 3 oxygens are formed. Ooh, that should say when, not with. Ooh, this one got tricky, right? These guys are formed. They're our products. These guys are our reactants. We have 2 options. I can just draw my arrow backwards like that and show my tin 2 oxide. That's going to be SNO because I've got +2 and -2. Nitrogen trifluoride, 1 nitrogen, 3 fluorines are going to react. So we can definitely write the arrow backwards. And now these are our reactants and these are our products. If you don't like that, you can totally just go the other way and flip the reactants and the products so that you've got your reactants on the left and products on the right. Either way, we're going to balance this guy. So I see SNONF, SNONF on both sides. We have 1, we have 1, we have 1, we have 3, we have 1, we have 3, we have 2, we have 2. So where to start? Pick an element, any element. I'm going to start with my oxygens. So I've got 3 and 1. I'm going to put a 3 here. So now I have 3 and 3. I'm going to fix my nitrogens. I have 2. I have 1. So I'm going to put a 2 here in front of NF3. Now I have 2 and I have 6. Uh-oh. So I need to fix my fluorines. I have 6. I have 2. I'm going to fix that by putting a 3 here. So 3 times 2 makes 6. That also changes my number of tins. I also now have 3 tins, but that's good because look, I had 3 tins over here. 3s, 3s, 2s, 6. We have some matches. So my final balanced equation is going to be 3SNO and 2 NF3s is going to yield 3 SNF2s and invisible 1 and 2O3. If you did it in this one, it's going to be the same numbers, just in different orders. So we'll have 3 SNF2s and invisible 1 and 2O3s are formed when we have 3 tin 2 oxides and 2 nitrogen trifluorides react. And my friends, you did it. We defined the law of conservation of mass, also called matter. Matter can neither be created nor destroyed. Make sure that you know that. We practiced counting atoms and chemical formulae, and then we learned a couple different ways for balancing those chemical equations. Good work today.